Hey, I'm Zach.
And I'm Jesse.
And you're watching In Depth
on Now You Know.
You can help support our channel by heading over to ecoware.us, where you're going to find new designs every week, and we carbon offset the production, shipping, and life cycle of every product, and then
we plant a tree for every order, which, since we already carbon offset, makes it carbon negative.
And we're brought to you by abetterrouteplanner.com. And you can use our link down below to get a 30-day free trial of the premium app. Plan your next EV trip with abetterrouteplanner.com. And we're sponsored by our friends at the solar-powered hotels in Schaumburg, Illinois, the Fairfield Inn and Suites by Marriott, and the Town Place Suite Hotel right next door. They're both connected, they're both solar-powered, and they both have EV charging.
I'm so excited about Battery Day. It's only 4 days away. Can't wait for Battery Day. We're going to learn all sorts of stuff.
What? I know, but why don't we just wait? It'll be like 5 days, and then Elon will just tell us what's going on.
Wait? I'm not going to be. I can't wait. I can't stop thinking about it. I want to talk to everyone about everything to do with Battery Day.
Okay. Well, if you want to talk about it, I do have some conjectures about what could take place, and I know that you've been busy on your computer doing something.
Yes.
With like tape measures and thumbs.
Yes.
So
we have to.
All right. Let's dive in.
Okay.
All right. So thanks to Gabe and Cal, we have great drone footage of the Tesla's Cato Road facility, which, as we know, Tesla pulled a building permit to build this second floor addition that you're seeing here. And we know that they've been advertising job listings for battery production engineers and managers.
And I mean, we knew this back in May. This is not new news.
Right. Now, when I first heard about this, I was a bit confused because even though this is a pretty big space, it's not a factory. It can't supply all of Tesla's batteries for all of its different projects around the world.
Right. When we had first started thinking about this, we thought that this would be a production line and that this is where all the batteries would come from. And the more we're thinking about it,
well, and the more we're seeing it,
it just doesn't make any sense because we have the Gigafactory in Nevada, the one that's pretty much already built, and it's huge, and that's where they make pretty much most of the batteries for Teslas. So it doesn't make too much sense that you'd be able to replace that Gigafactory with like a small-ish building relatively.
Exactly. So that's when I realized what Elon is doing. He's creating an incubator. This facility at Cato Road will figure out new battery chemistries, but it will also figure out how to make those battery chemistries at scale so that Tesla can repeat that at other gigafactories around the world.
Okay, so you're saying this is like their test site. It's really close to home, so Elon can pop in if he wants to. He doesn't have to get on a plane. He just, scoots down the street. He pops in and he says, "Oh, hey, how are the batteries going?" And Jeffrey Don is, "Oh, I have a fresh batch here. You want to try one?" That's kind of the way it's going to be. And then when they're like, "We finally got the battery that we were looking for, we'll take a bunch of pictures, send that off to, Gigafactory China or Gigafactory Texas, and they'll start producing the batteries there."
Right. Not just making the batteries, but how to make the batteries. Right. So basically, once you get that correct, you can then just copy paste at the gigafactories all around the world. So by now, we all know that Tesla bought Maxwell Technologies, which gives them two cool technologies, right? Dry electrode process, which should reduce the cost, the time, the energy to make batteries and maybe even increase the energy density,
right?
And ultracapacitors, which is something that Maxwell makes. Now, early on, I got really excited by the idea of ultracapacitors. These are able to absorb and release a lot of energy very quickly, which is really helpful with regenerative braking or accelerating quickly, for example, with the semi-truck or the Roadster.
But then Elon put out some stuff that made it sound like he wasn't going to do ultracapacitors. Then he said that he kind of is. So now we're excited because maybe there will be ultracapacitors. But I don't think that we know enough to be able to conjecture on this because there's no mention, there's no leaks, there's nothing that we really know.
Well, we do know this, though. We've got the new Tesla patent for the tabless electrode, and that could be huge. And now we can couple that with this, which are new images coming out from Electric of what could be a new battery cell.
That's a big battery. That's a honkin', chonkin' battery. You take your 18650. This was the one that came from, the Model S and the Model X. This is like the smallest battery that Tesla puts in their cars. Right. Now, then there's the 2170s, and then there's this huge, big battery. So what are we looking at here?
Well, if this is indeed the new Tesla battery, and according to Electric, these pictures allegedly leaked from some engineer in Tesla's Cato Road facility, showing this larger battery. Now, this is estimated by Electric to be double the diameter of the 2170, that's used on the Model 3. So if more batteries is better, wouldn't this mean that you'd have less batteries in the car if you're making bigger batteries? And isn't that bad?
Okay, well, this isn't necessarily so important. You need a certain number of batteries in order to get the series right. So that creates your pack voltage. And then the number of cells you have in parallel determines the number of amps. But if each of those cells has a higher amperage rating, so the amount of amps that you could draw from that cell, then you don't necessarily need quite as many cells.
Okay, but if we're making a bigger battery, bigger circle, won't you be able to fit less of them in the pack because there'll be more space between the batteries?
Well, again, it's not about number. And in fact, the packing density will remain the same because that's just math. Here's a quick equation to show you circular packing density.
Okay.
The most optimized version is about 90% dense by area. So if we're assuming that these are all circles, even though they're cylinders, and you were to pack them all up, you would get about 90% dense no matter what the diameter of those cells is.
Okay, well, if bigger seems to be better, then why didn't they just do this before? Why didn't they make a bigger battery years ago?
Well, that's a good question. There are some problems with making a larger battery. One of them is heat. So the more amps you're pulling out of something, the more heat is coming out.
Oh, right, because that electron that's in the very center of the pack has to go around and around and around and around before it gets out, and that creates heat.
You can sort of imagine a battery like this to sort of be like a Swiss roll of, instead of a yummy, delicious pastry, it's actually a battery. And so that roll, that long roll, means that, the electricity has to travel that whole roll to get out. And so the wider you made that, the longer it would have to go, the more heat would be accumulated in the battery. And also, the further away from the outside of the battery you'd be to try and pull that heat away by any cooling system that you'd have.
Oh, but the new tabless technology could allow them to just shoot the electron beep, right out
the front of the battery. And that would significantly reduce heat, but it would also give you some more advantages.
Okay, so bigger must mean a higher density watt hours per kilogram, right?
Not necessarily. It appears that according to Inside EV's calculations, Tesla didn't achieve much difference in energy density when they switched from the Model S 18650, this one, to the Model 3's 2170 cells. You can see on this chart here that the actual energy density went down by just the tiniest little bit.
Well, then who cares if you make a bigger cell? That seems pointless.
Well, there are two huge differences. So the first one is power. So going back to the example of the Model S and the Model 3 cells, for a 50% bigger cell, which is pretty much exactly the 18650 to the 2170 was 50% bigger, you get a doubling in the amount of current that you can pull from that battery. So you could pull about 3,000 milliamps from the 18650, that's 3 amps. And the 2170 has been tested at about 6,000 milliamps or 6 amps.
Yeah, but you just made it bigger, so that's why you could do that.
Yes, but you only made it 50% bigger, and it got twice as power dense.
Oh.
Not energy dense, power dense. It had more power in it.
Okay, so this means that the new cell is twice the current of the 2170, so it went from 6 amps to 12 amps. Wow, so the new cell is going to be 12 amps?
No. Not so fast. The new cell, let's call it the 4576.
Wait, what? How are you naming it?
So I did a little bit of sleuthing here.
Oh, that's what you were doing at your desk all afternoon.
So I took the image that we got from Electric. This leaked image might have come from someone from Tesla. It has been confirmed by independent sources according to Electric. So it might be legit, might be completely fake. But assuming it's real, I assumed that my thumb was the same as this guy who took the picture.
Okay.
I was able to line my thumb up exactly with his thumb.
Okay.
So pretty much the same shaped thumb and everything. You know, the thumbnail's roughly the same size. All of that seemed to check out. Then I measured the height in roughly the same place while lining it up so I could see the battery. And I got 3 inches or 76 millimeters.
Okay, so the new cell is 76 millimeters high, so that gives you the 76 in your 4576. Where'd you get the 45?
So then I took a look at the picture. I took some lines. I drew them across so I could, compare the height with the diameter. Then I was able to figure out roughly the ratio between the diameter and the height. So it was about 60% the diameter of the height. So that gave me the 45 millimeters wide diameter.
Okay, so you're calling this the 4576 battery based on your calculations.
And it's not I'm sure it's not exactly those specifications, but that gives us kind of some numbers to play around with.
Okay, so I get that. So now we know the volume of this new cell. So how does that compare to a 2170?
So this new cell, the 4576, has a volume that is about 5 times larger than the 2170.
Wait a minute. The 4576 is 5 times the volume of the 2170?
Yes. And so that means that it is definitely not twice the current. It's actually 16 times the current.
How did you get that? If it's 5, why don't you just multiply it times 5?
Well, when Tesla went from the 18650 to the 2170, they increased the volume by 50% and the current went up by 2 times.
Okay.
Now they are increasing the volume by 400%. So the math looks like this. 400%, which is just 4, divided by 50%, you could just say 0.5, times 2 equals 16. So 16 times more current.
Wait, so what's the current of a 4576 cell?
96 amps.
What? Wait, so the 2170 cell was 6 amps, and this new battery could be 96 amps?
If... and I want to stress, if Tesla was able to maintain the ratio, the 50% to 2, and I can't tell you if they would be able to do that because I'm not a battery scientist, then if they were able to maintain that ratio, then yes, it would be a 96 amp cell. That's not 96 amp hours, that's 96 amps that you can draw. So whatever the capacity would be, I didn't calculate that, times the C rating, which we assume went up from the 18650 to the 2170. So we can assume that it's going to go up on this one since they're going to throw in some nice stuff into it. Now this could be lower than 96 amps, but let's take a look at what this means if I'm right. Just because you can always lower the outcomes by some factor to be more conservative. But let's take a look at the long-range Model 3 battery pack. Currently has 4,416 2170 cells.
Okay, 4,416 cells. Okay.
So it is a 96S46P pack.
Okay, and to learn more about what we're talking about here with series and parallel, go check out our electric lawnmower series where we actually built a battery pack right there, and we explained the whole thing.
So basically you have 96 batteries in series, 46 in parallel. That means that you have 276 amps and roughly a 400 volt pack with 75 kilowatt hours of actual energy storage.
Okay, so that's for the Model 3 existing pack.
Yes. So if I'm right, then to achieve the same 400 volts, Tesla would still need to put 96 of these cells in series.
Wait a minute, wouldn't it be less in series?
No, because the voltage doesn't change, because the battery chemistry determines the voltage. So because we're just assuming that these are still lithium ions, we're going to assume that they have, the 4.2 volts when they're fully charged and the 3.7 nominal. So let's just assume that we're keeping the 96S.
Okay.
But now we need to determine the P.
Determine the P?
We need to determine how many cells are going to be in parallel.
Right.
Last time it was 46. This time we're going to change that number. So if we were to assume that there were 1/5 the cells...
Now, where did you get 1/5 the cells?
Well, remember that the new 4576 is 5 times the volume of the 2170. So we only have the room to put 1/5 the cells in the same place, and it should roughly come out to being the same number of kilowatt hours.
Okay, I gotcha.
So with 1/5 the cells, that would put us at 883.2 cells.
0.2?
Yeah, we're going to need to fix that. So 883.2 divided by 96, which is the number of cells in series, gets us 9.2. And since we can't have 0.2 cells in parallel, let's round down to 9.
Okay, so we have 9 cells in parallel. So this is a 96 series 9 parallel pack. 96S, 9P.
Now this means that there are 864 cells in the new Model 3 battery pack.
Wait, only 864 cells? Will that be enough amps?
Well, let's do the math. 9P, so 9 cells in parallel, times the 96 amps of each cell would get us 864 amps.
Wait, how many amps was it before in the regular Model 3 pack?
It was just a 276 amp pack.
Well, wait. So we just reduced the number of cells by 3,500, and we kept the voltage the same, but we increased the amps by 588 amps?
And that tells us how many kilowatts this battery would be able to put out. Now remember, kids, that volts times amps equals watts. And if we do the math, that gets us 348 kilowatts.
Wow, what was the old pack?
The old pack could only put out 111 kilowatts.
Wait, so that's the amount of power that can be drawn from the battery at any given point, is 348 kilowatts. That's 3 times what the old pack could put out?
In theory. And again, I'm not a battery scientist. I'm just using math and some assumptions. And even if I'm off, this is still incredible. And you know what? I'm not even done yet.
You're not done yet?
No, remember, this is just difference 1. There is still difference number 2.
What's that?
Cost. Remember that when Tesla went from the 18650 to the 2170, they kept the cell cost the same.
So what?
Well, the Model S 75 had 5,880 cells, and the Model 3 75 had 4,416, nearly 1,500 fewer cells that cost the same.
Oh, so make a new 4576 cell for about the same price as a 2170 cell.
Right. And then in theory, the price of the Model 3 battery pack could drop by a factor of 5.
All right, so let me get this straight. We don't know what the existing Model 3 battery pack costs, but let's assume that Tesla's costs are about $100 per kilowatt hour. That would make a Model 3 long-range battery pack cost about $7,500 today. So if you're right, and Tesla can reduce the cost by 4/5, then are you saying that Tesla could reduce the price of the Model 3 long-range with new 4576 batteries by $6,000?
Look, we're probably off, but if the cost of those cells is, say, twice as much as I think, then Tesla could save about $3,000 per battery pack. And that's about a 7.5% cheaper car.
Wow. Okay, so I get that there's a cost savings to Tesla, but how do the increased amps help Tesla?
So the increase in available power would allow Tesla to use beefier motors for more performance. And conversely, those amps could be used in reverse to charge the car, which means that more regen energy could be captured, making the car more efficient overall.
Meaning you wouldn't need as many batteries, meaning the car would be more efficient because it would be lighter. And you could probably charge the car faster.
Exactly. And just to be clear, we are making a lot of assumptions. Now, you might be saying, wait, they could charge the car faster? You don't want to do that because you're going to need beefier cables because you're going to be pulling more amps through them. One other thing they could do would be to run more batteries in series, increase the pack voltage up to, say, 800 volts, which other car manufacturers have already done, and then increase the charging speed while keeping the same amps running through the cable because it'll be at a higher voltage, which means you'll get the same number of kilowatts through the cable, but at a higher voltage with less amps.
So basically, this battery just gives them more options at less cost.
Exactly. And the problem with Tesla's batteries to begin with was that you needed a lot of them in order to provide the same amount of power, which would give you a pretty good range. I mean, they've always had roughly a 200 or more mile range. But in order to get more performance, you needed a bigger battery pack. So, for instance, the P100D needed the 100 kilowatt hour battery pack. If you can draw a higher amp from the pack, you could have a smaller battery, which means that the car is lighter. You can have smaller brakes, which means more performance. You could have a super, really nice sports car with a smaller-ish range if you wanted to, or you keep the range the same and just put beefier motors on it and still have more performance. So it's a pretty big win for Tesla no matter which way you look at it.
So, I mean, even if Battery Day doesn't include any of the other cool ideas we've conjectured in past episodes, like VPP, which is a virtual power plant, or V2G, which is vehicle to grid, or the million-mile battery, or ultracapacitors, even if it's just this one new technological leap, this could be a game changer, a price reduction and power increase that nobody else has.
And Tesla could license this to other battery manufacturers. And I mean, there's really no reason not to.
Right. I mean, they could move sustainable transportation forward and profit from other manufacturers at the same time.
And let's not forget that as the price of EVs comes down and the performance goes up, ICE cars cannot compete. And we're getting very close to that crossing of curves so much faster than anyone had ever predicted.
And the good news is that in about 5 days from now, we're going to know.
We'll know. So don't stress too much about it. If you think that our numbers are wildly off, feel free to tell us in the comments. But don't worry, because we're all going to know in 4 days' time.
And if you're like me and you're planning on, clearing your schedule for Battery Day, we're going to be trying to do a live stream of Battery Day so that we can kind of comment and give our thoughts, and we can have the whole community there giving their thoughts while Battery Day is going on. Because there's plenty of time during these presentations where there's like delays and you're sitting there. And
it's also an investor day. So there's all sorts of voting on boring stuff of like, why don't you guys have commercials? And it's like, we're not going to do commercials.
Well, and we're voting on whether Elon should be a director. That's a big deal.
That's a big deal, but I think that we're all in agreement that kicking him out would be the worst idea ever.
Yeah, so if we can get the tech going, please join us for Battery Day, where we'll be live streaming with you guys. It should be a lot of fun hanging out.
Yeah. And it's going to be so exciting. I can't wait. Even if our live stream machine blows up and we're not able to do it, it's going to be amazing.
Yeah, 1:30 Pacific on September 22nd. Be there.
Or be square. Thanks so much for watching. Now you know.